Hello, this is Mrs. Taylor, and I would like to show you how to solve equations using algebra tiles. So if we have this equation here, 4x plus 2 equals 10, and we're asked to solve the equation. First, before we get started with that process, let's understand what that means. Solve means that we are to use inverse operations to isolate the variable. And what that means is that I want to undo what is being done to the variable. So I have 4x plus 2, and that means that I am taking x and multiplying it by 4 and then adding 2 to that quantity. Well, when you are working with inverses, you want to go in the opposite direction, opposite order of the order of operations. So we would first want to undo adding 2 by subtracting 2, and then undo the multiplication by dividing. Now, if that process is too abstract, we can use algebra tiles to help us make sense of it. So if I represent this equation first by using 4 positive x's, so I have my 4x, plus 2, so I need 2 positive 2's. And then on the right side of my equal sign, I would need 10 positive 1's. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now I have my equation set up, and if you look, this symbol in the middle transformed to an equal sign. And the reason why it's doing that is because we've seen where we're supposed to approach an equation like a balance scale. The left and the right side are balanced because they're equal. So I don't want to knock that balance off by doing something on one side of my scale and not the same thing on the other. If my goal is to isolate the variable, then whatever I do to do that, I have to do on both sides of my balance scale. So the first thing I'm going to do is work with my units, my 2 positive 1's over here with the x's. I want to isolate the x, so I need to get rid of those positive 2's. And what we've learned with algebra tiles is the way you do that is you use the opposite, so a positive 1, a negative 1, those are opposite, and you combine those together so that they combine to 0 and eliminate. In class I like to say we neutralize them. And so if I would like to eliminate these 2 positive 1's, I would throw in 2 negative 1's on that side of my balance scale. Well, remember, whatever I do on one side, I have to do the other. So I'm going to bring a couple of negative 1's to the right side, and if you look, I'm back to an equivalent relationship. Now, what we learned about the algebra tiles is when I have opposite pairs, I can bring them together, and they would add to 0 and disappear. So now I'm left with my x's on the left side and my 1's on the right. Well, the division part looks a little bit different. We want to break this into equal sections. So I have 4 x's here, and I want to find out how much each x represents. So if I take my units, my positive units of 1, and divide that equally into 4 sections, what I notice is that I can do that so that each x represents exactly 2 positive 1 units. So I have, once I divide this up, and it'd help if I used a color you could actually see, 1x is equal to 2 positive 1's. And so what that tells me is that in my equation, x equals 2. And I can make sure that's true by checking my balance scale here. As I go, making sure that I've checked my work. Once I have one x on the left and two positive ones on the right, I'm back to an equal sign. So this is what solving equations look like with algebra tiles. If I were to do this by hand, my steps would reflect what I did. In other words, I could show the elimination of those positive 2's by subtracting them from both sides here. 2 minus 2 is 0, so I would have 4x plus 0, and 10 minus 2 is 8. And then once I have that step, 4x plus 0 is just 4x. And then I could show my dividing this into 4 equal groups by dividing my equation over here. And what that would look like is we would use a little fraction bar to show the division part, and I would divide both sides by 4. And then 4 divided by 4 is 1, and 8 divided by 4 is 2, and we know that 1 times x is just x. So my solution is x equals 2. So I arrived there at the same solution using inverse operations here, or using that concept of inverse operations in a balancing scale with the algebra tiles.